So this video is going to probably be a bit of a rambling video, but I wanted to do something on essentially around assemblies, the use of assemblies and interfaces, the impact of that on compilation time, and illustrate the data, I guess minute to minute, hour to hour, day to day impact of that on testing, particularly around unit testing. So I'm going to do this. I'm going to set some context with an example project, just for a start off, and then just show some examples of how we can kind of what happens when we separate things out. So as an example, I've kind of looked at a fairly large project that has a number of different assemblies in it. The organisation of that is not necessarily kind of particularly. It's not necessarily kind of strategically structured for any particular purpose, but I just wanted to kind of use that as an exemplar. So this particular solution has got a web service backend and then a web application front end. And what I've got here is I've got a hopefully you can see that I've got this thing here showing the complete solution, and I've got then all the different assemblies within the solution, and the web service is represented by this line here, host, and the web application front end is represented by web UI. And then there's various other bits of code and stuff that goes into making up those two kind of main projects, and there's various dependencies between them. And what I've not done here is listed the dependencies between them, although I will talk briefly about that. So a few things to mention. So if I want to, I've tried kind of going through Visual Studio and run various different tests. So for example, if I build the entire solution from scratch, that takes 23 seconds. So that assumes that nothing has been built, and they're kind of building. If I do a rebuild of that, sorry, not rebuild. If I build a solution and then I build the solution again, the second time around it takes about a second. It takes really longer to kind of go through the setup and kind of shut down kind of process of compiling than to do the actual work. So once the code is compiled, running the build again when it's already done the compilation, is very, very fast. But the key thing to remember here is that whenever something changes in one of the assemblies, that assembly and anything which depends on that assembly need to be recompiled. So if you had let's say 9 assemblies in your project, and each assembly was dependent on the next assembly, and that one dependent on that one, that one on that one, that one on that one, and so on. So you could basically get a daisy chain of dependencies, and you changed something in the end of that dependency, then you would have to you would end up kind of recompiling, kind of back up the line, recompiling everything. And if when you're at the start of a project, and your project is small and you don't have many lines of code, you don't have much to compile, the desire to sort of split things out into different assemblies, and how to do that, when to do that, why to do that, possibly seems highly irrelevant, not particularly interesting to what you're doing. The only way you come across different assemblies is if you're using kind of third-party libraries. You're probably not separating out your code into different things unless you really kind of have to. So in the case of here, we had to have one application for the web services, one application for the web application, but I guess we may not have necessarily needed anything else. So there's possibly not, when the project is small, it has kind of perhaps less of an impact. As the project starts to go up in size, the desire to understand when and how and why to kind of break things out, why to structure things in a certain way, probably becomes kind of more important. So obviously it presumably stands to reason that the more lines of code there are to compile, the longer the process will take to compile. So naturally, therefore, over time, if you're writing code and let's say after the first day you've got 10 lines of code, after the first week you've got 100 lines of code, after the first 2 months, 3 months, you've got 1,000 lines of code, it's 10,000 lines. You naturally have to go through a testing process of where you write code, then you test it, you write code, test it, write code, test it. And and because you're writing code, compiling it, testing it, write code, compiling it, testing it, write code, compiling it, test it, the more code you have to compile, the more impact that compilation has on the efficiency of that code, compile, test cycle. So when you've got 10 lines of code or 100 lines of code or whatever, that compilation time is probably next to nothing. So your coding time is kind of maximized, and your testing time is kind of maximized, and your compilation time is irrelevant. Then fast forward, a year or 2 years down the line, you've now got tens of thousands of lines or hundreds of thousands of lines or whatever it is. If you're still having to compile all of that code, and all of a sudden that's now going to have a significant impact. So, if you're making, particularly if you're going through a debugging process where you're making very small changes, compiling, testing, if you make a change that takes 5 seconds to make the change, and then you compile, and your compilation takes 20, 30 seconds to compile, and then you run your test, all of a sudden now your working hours are now dominated by waiting for code to compile. Whereas you want to be the ninja developer. You want to be maximizing the time that you spend coding. Ideally, you make the compilation as fast as possible. You make the testing as automated and as fast as possible, so that you can maximize the amount of time that you've got eyes on the code, and adding your brain power to that. Whilst you're waiting for code to compile, you're probably not really kind of doing. You may be thinking about other things, but you're probably not as productive or as useful as you would be if you were fully concentrating on the work you're doing on the code. And obviously, the speed of your machine is going to have an impact on this. I've given some sort of timings here for how long particular things took to compile, and a particular solution on a particular computer may be faster or slower. But unless your computer is exceptionally fast, then these things are going to be relative. So, if it takes 20 seconds on one machine, it takes 15 seconds on another. It's still 15 seconds. It's still a chunk of time. It's still a significant drain on your efficiency. And I absolutely advocate the idea of the lazy developer, and doing as much as possible with as little effort. and we don't want to be in a situation where to improve our output, to improve the quantity of our output, because the quality of our output is important, but equally, if we can have a load of good quality code, then twice as much good quality code is still preferable. And one way we can achieve that is through dedicating more time to our work. Ideally, there may be reasons for either wanting to do that, being prepared to do that, or whatever. But there is a limit to how much you can do that, and how much would be advised to do that. So there comes a point where actually you want to say, how can I be more efficient with the time that I do want to invest in this? Do I want to spend 12 hours to achieve this amount of output, when maybe I could achieve the same amount of output in 4 hours? It'd be nice to achieve that same output in 4 hours. What you then do with that time that you've freed up, that's a different conversation. But one would hope that the idea of spending the least amount of time to achieve the output that you want would be desirable on both a personal level and on a organizational level. So a few things about this. We've got a number of different assembly. Our solution is broken down into a number of different assemblies. Now, whilst it may look like there's a kind of a structure to this, there isn't. It's possibly not as kind of as well structured as it might look. So, for example, we have a business assembly, which, aside from the slightly kind of generic naming, it does contain business logic, but that business logic itself is kind of wrapped in web services. So it's actually, we've got a lot of code there that is highly relevant to our application, but actually kind of quite rigidly defined within a web service framework. We then, for example, have this interfaces assembly, which is not interfaces that are used by our model code. It's actually just the Windows WCF interface files. So that's literally just the furniture that's needed for setting up WCF. So we're quite, this particular code base doesn't really make effective use of interfaces. It doesn't have kind of clear separation between kind of say the business logic and framework logic. But what that means, so I say it takes 23 seconds to build the entire solution. And so ideally we want to be doing that. We're never going to get away from that. If you've got a solution that's got 77,000 lines of code in it, it's going to take a while to compile. What we want to do is minimize the amount of time that we need to recompile the entire solution. And I've done I've broken this down a little bit to sort of show the relative time. So if I build each of the individual projects within the solution, how long each one takes, and you might notice that there isn't much of a correlation between the amount of time it takes and the amount of lines and the number of lines of code within that particular assembly, and that really just illustrates the dependencies between, or more, I think more than anything, it illustrates the dependencies between different assemblies. So, for example, the host assembly takes a relatively long time to build, has very few lines of code, and this is actual lines of C# code. So I don't think this is not looking at any of the configuration code. It's not looking at white space or blank lines, that kind of stuff. It's literally just looking at lines of C# code. Take 8 seconds to compile, yet only has 72 lines of code, but it has dependencies on other assemblies. So it's taking those into account when it builds. But you'll see that most of the assemblies that we have take time to build. Now, because we're also the other thing to mention is because our business assembly is heavily kind of hooked into the web service framework. The WCF framework code, it makes that quite difficult to bring that code under test anyway. But I guess kind of what I want to sort of try and demonstrate is well. So before we get into that, if I to highlight one of the issues around the kind of what happens in terms of the recompiling code, I went into one of the files in this assembly, the business assembly, and I changed one line, just declared a new variable, and I then attempted to build the host assembly. Bear in mind, so I could build the host assembly, and it will take 8 seconds from there being kind of nothing built. So just building the host assembly and whatever other assemblies it is dependent on. If I then build the host assembly again, having already built it, it takes virtually no time, perhaps a second. If I change one line in that business assembly, then the impact of that on then compiling the host assembly is that takes around 6 seconds, because it builds the business assembly and then it builds the host assembly. Now, you might think that some of the maths there doesn't add up, but obviously bear in mind that the business assembly has dependencies that go into making up that 9 seconds. It has to compile itself, and it has to compile its code that assembly is dependent on. Likewise, the host assembly compiles other dependencies as well as the business assembly. So that 6 seconds doesn't include the time it takes to build the dependencies of the business assembly, because they're already built. They don't need to be rebuilt just because this code has changed. The only assemblies that need to be built are the business assembly and the host assembly in this case. So any other dependencies, don't need to be rebuilt. So what we have got about, obviously that assembly is about 28,000 lines of code. So it's getting on for roughly half of our, well, I guess just under half of our code base, perhaps 40% of our code base. And bear in mind that because our business logic is mostly defined within there, mixed in with the web service kind of logic, which we don't want, but nonetheless most of our business logic is defined within there. It's likely that that's going to be where we make most of our changes. So therefore, most of the time, we're going to need to recompile that assembly whenever we want to test something. It's less likely that the other assemblies are going to change. And I guess the other thing to kind of mention is the web UI one. That again has got a significant amount of our code in it. That's in part because we've got quite big controllers. But I'd say the main the main thing that I'll kind of draw on here is the fact that we've got most of our business logic in one place, in one assembly. So compiling that takes some time, and if we change it, we need to recompile the host. And say that we've got some challenges around kind of how we can test that, simply because of how dependent we are on that kind of web service framework, or the WCF structures. So I hope that's given some background around where that, how having these assemblies, how the dependencies kind of work. That if you've got one assembly that's dependent on another assembly, and you want to kind of rebuild that stuff, then it's going to take time. If you've got tests, if you've got functional test scripts that are going to be testing the interface of the web services or the interface of the web application, and it's got a dependency to kind of build all of this stuff, then chances are your compilation time is going to be quite high, and that cycle time between the kind of coding, testing, also coding, compiling, testing, is going to end up being dominated by that compilation time. So we want to try and use the techniques we have available to us to have a positive impact on that. And like anything, the things I'm going to show you are that it is a tool in the toolbox. It's not there to be kind of abused and used for everything, but it is a tool that can be used. So let me kind of show you something. So what I've done here is I've created a blank solution, and in that I'm going to add two projects. I'm going to add a console application, and I'm going to add a test project. And I'm going to do that. I'm going to create a console application that has just got a basic, that's got a score manager that dumps out score information, and I'm going to use that just to illustrate the kind of the way we can use assemblies to separate things and impact on how things compile. So let me create that first up. So we'll call that test. We'll call it demo app, actually, not test, because a bit confusing otherwise. So I've created a demo console application, and we'll also add a test application. We said this is going to be a scoring manager, so we'll do the so we call this scoring tests. I should say I've been through some of this stuff already, so I'm kind of working through a kind of an idea I'd kind of had previously. So this application kind of runs. Let's just build that. So we can see that when we build the solution, it builds demo app, and it builds scoring tests. So that's just built the solution. If I go in here and I tell it to build demo app, it just builds demo app because there's no dependencies. If I do scoring tests and try and do that, that also just builds scoring tests, because at the moment there's no dependency between scoring tests and demo app, or between demo app and scoring tests. So I could, if I wanted to. So the desire for this is to output something that dumps out a score in XML. So all I'm going to do, just for the moment, is to be a really kind of contrived solution. But let's say, I've output some XML like that. So now So that's all I'm doing. I'm just outputting some XML, and that's in my demo app, my little console application. But if we sort of take that contrived example a bit further and say, well, what about if the console application was only going to be one of the things that was going to be used to output this data? What happens if we wanted to output this data in more places? So we could probably say, well, actually, let's kind of extract that from there and actually kind of do our logic somewhere else. So in order to do that, I'm going to create a new class, and I'm going to call that Score Manager. And in Score Manager, I'm going to have a print function. And that is going to take that code. And I can now say from here, let's say have a score manager, sm equals new score manager, and we're going to say sm dot print. So that's good. Now so our functionality is now kind of separated out into a separate class. So our application is here. We've got a separate class here. It's now actually kind of, could argue a little bit easier to test. We we're not testing the application here. We can test the we can just kind of test the score manager. So it's score manager tests. Let's just update that. Let's just create the object to test that. So I'm going to say score manager equals new score manager. It's not very good, is it? Score manager, and we're going to do sm.print. I'm going to get a complaint here because we can't access score manager. So I hope it's kind of it's kind of obvious here that because scoring test is one assembly and demo app is another assembly, score manager is in the demo app assembly, and we want to test it. So therefore, the scoring test assembly needs a dependency on demo app, which is what's being suggested here by Visual Studio. So we can add that reference. So that dependency will have now been added. We've still got an error here because even though we've now got the reference added, we still need to add the namespace, because the namespace for Score Manager is different from Score Manager tests. So we'll add that there. Now we see that that's working. So with just a relatively kind of small amount of effort there, we've now managed to kind of bring our code for Score Manager out into a separate class that can be used by anything else. We've got our program here that still functions, and now we can actually test the Score Manager in isolation of the program code. So that seems like quite a nice nice situation to be in. If I want to build demo app, I build that, and we can see that demo app gets built. It doesn't do anything with scoring tests. If I build scoring tests, then we can see it builds demo app and it builds scoring tests, because we've got that reference in here, because Score Manager is part of demo app, and therefore in order to build our tests, we need to build our application. So now we've got this. So our Score Manager is outputting XML, and it can be used. That class can be used by anything else. It doesn't have to be just used by our console program. It could be used by something else. But what happens if we want to change the way that data gets output? What happens if we want to output it as, say, JSON rather than XML? So one thing we could do here is we can update our function there to be called print XML. And we could add another function called print JSON. And in here, we could then change that to some basic JSON notation. Someone's going to tell me that I've done this wrong, but we can do that. And then we've got print XML option, which is great. We need to go and update our code here because that will fail otherwise. That will fail. Let's actually take that. Let's make another test. So that was create object. So we'll just get rid of the print XML from there. Test XML. So it's going to do that, and we can do another one for test JSON. We can do that JSON. There we go. And all is well with the world. Now we could let's try and make our score manager a little bit more flexible. Let's have the ability to actually manage a score. So let's set score s score equals s, and then let's output score just there. So now perhaps we can go in here and we can say sm.set score 10. Let's also give that, just in case, let's give that a default value as well. Okay, so now we've given that scores, but one could argue here that let's just also recompile that again. Let's just check that we can compile everything. We can compile our demo app. Just compiles demo app. We compile scoring tests. Compiles demo app and scoring tests. Now we could leave it like that, but at the moment we're outputting XML, we're outputting JSON. We might want to output something else as well, and we're making the score manager responsible for understanding how to do each of those outputs. So it'd be quite nice if actually we could make something else responsible for that kind of formatting stuff. So one of the ways we can do that, for example, that would simplify the implementation here, is to create some sort of printer object that we give to the score manager, so the score manager can then just kind of output the things it needs without needing to worry about kind of how that gets implemented. So again, I'd kind of refactor this and say, well, let's let's create if we're doing that, we're going to say we want to create an XML printer, and that's going to be called XP, and that's going to be equals new XML printer, and we want to be able to pass XP into there. We want to be able to set the score as normal, we want to be able to print, and we want that to print XML. Let's just get rid of the JSON one for the moment. Don't really kind of care too much about that for the time being. So we've updated our test. That's now kind of broken a few things because we don't have an XML printer class. We don't have a constructor of score manager that takes XP, and we also don't have a print function anymore. So let's create a new class in here called XML printer. Let's give it that function, and we'll just we'll make it slightly more generic. So rather than printing scores, it'll just print data like that. So we could reuse that for anything that wants to output a bit of data inside a output some data in a basic XML data node. So we come back to our score manager. We're going to change that to be print. We're going to say we need to give it a XML printer XP. We need to tell it that it has a constructor and that's going to take an XML printer, and that's going to set that here's XP equals underscore XP. Let's go back to our printer here. Let's just make that public. We've got a set score, we've got our print function, so that's just going to do XP dot print, and all we're going to do now is pass in our score value. So that's quite nice. We can do that. We can see here that we now don't have a constructor that allows us to just create a score manager without a printer, so we'll just do that. Now we seem to have got that. Seems to have got that working. We can go back to here. We can see that our score manager in the main application. Well, let's just try our scoring tests. We'll see that that won't compile. We can't run our scoring tests. We can't compile scoring tests because it's dependent on the demo app, and the program itself is broken. So before we can run our tests, we need to fix the main application, which I guess it's not ideal, but we'll come on to that in a bit. So I'll create a new XML printer. I'll pass that in just there, and I'll update that code there. So now when I run scoring test build, that builds successfully. Demo app, that also builds. So all is well with the world. We can extend our test just to make sure. We want to get our JSON code working as well. So let's create a JSON printer. And let's create we've got a new score manager there, and we're going to call that one JP rather than XP, JP, we're going to set score and we're going to print. So now we've got an issue in that the JSON printer doesn't exist. So we now need to go back to our demo app, add a new class. That's going to be called JSON printer. And we can just copy from our XML printer the same method. We'll make that class public as well. We know that needs to be public. And we'll also then copy from Score Manager the code that we need to pass it, that we need in here. And we know that's going to just be data. So now we've, oh, that's the wrong one. That's the wrong one. It's this one. So that's, copy that over to there in the JSON printer. Update that, change that to data. So now we have a JSON printer that prints JSON, and we have an XML printer that prints XML. So and our tests here are, oh, we missed our, lost our public declaration off there. So that's all fine. We can go and try and recompile our scoring tests. But we've got a problem. We've got a problem. We can see here that our score manager is actually not working. It doesn't like our JSON printer. And if we look at that, we can see it's because it's dependent on an XML printer. So the way we can do this, the mechanism that's kind of afforded to us for this, is to create an interface that both JSON printer and XML printer conform to, and then make Score Manager dependent on the interface rather than a concrete class. So if I go to our XML printer and I go to, I think I can do this from here. Why can I do this? Extract interface, look at that. So I can create a new interface, which I'm going to call iPrintable, and it's going to implement the print method. So there we have our iPrintable interface, and we can see that our XML printer is conforming to that. So we can now take that to our Score Manager and say we're going to make that iPrintable instead, which is all grand. If we go to our scoring test, we'll see that's still not working because we need to make JSON printer conform to that as well. But once we do that, we should find, now it works. So we've just there now made this kind of quite nice that we can now print in anything, and we could add, if we wanted to, we could add a new printer that outputs in whatever format, YAML. We can make a YAML printer, and we could pass that in. In fact, let's do that. So we can. In fact, I'm not going to do that yet. I'll show that kind of a little bit later to just demonstrate some of the other things. So we have got a situation here where, in order to run our tests, we need to build both the demo app and the scoring tests. So two assemblies both need to be built. And we also need to make, therefore, our demo app needs to be fully compilable. So if we've made any mistakes in any of this in our program, even though our program isn't used by the tests, if the program won't compile, then we can't run our tests. So one of the ways we could do that is to extract our the logic around our kind of score manager and stuff, and the things that that's using, extract that to a new assembly. that handles our scoring stuff. So if I just do add new project, and I'll create this as a library. This will be our score. Let's call this our scoring library. So we've got that there. We'll delete the class that it gives us. And what I'll do is I'll move I'll move these files across to scoring, and I'll delete them from here. So now our demo app is just a program. I'm also going to just update the namespace on this, just for the purpose of making things easy. So now we will see that lots of things will start to break. So we can't do so because our code can't find anything now. So if we go back to our score manager tests, we're using demo app. Demo app doesn't contain anything anymore. So our references are now our references are wrong. So I'm going to go to add reference. I'm going to untick demo app because we don't need that anymore. Well, in fact, if I leave that, if I add scoring in there, and I now change, because I've changed the namespace of all of that code, change the namespace to scoring, you see that everything now works. If I now compile scoring tests, again that's kind of failing now because of program.cs. But if I don't need demo app anymore, so I can come out of that, and hopefully I should be able to build this now. I can, so I can build scoring tests as dependent on scoring. Program.cs doesn't work. Program.cs won't compile, so I can try and build that. And that's failing because of the refactoring that I've done. But our tests can work, and our tests are now no longer dependent on our program compiling. So we just need to compile this stuff here. So for the sake of just making this work, we're going to just fix this. So we're going to add a dependency on not scoring tests, on scoring, and we're going to add a using scoring statement in there. So now that our demo app should also now compile. But I could kind of argue here that our printer stuff, they're just utilities. They're just utilities. They're not part of scoring. We've created a library for our scoring kind of code that could be used by other things, but the printer's got nothing really to do with the scoring. So what I could do here is add another new if I add another new printer to my scoring library, then again that code needs to compile in order for my scoring test to work. And whether my score manager uses that printer or not, bearing in mind that my printers can be more generic, can be used for other things, my score manager might not use the new printers. My tests are still going to be dependent on that code compiling and going through the process of compiling that code. So, we could say, well, should we have that kind of dependency? Should I need to compile all that stuff in order to make this work? One of the things that I can do is to say, right, I'm going to add a new project, and it's going to be another library, but it's going to be my printing library. And I'm going to go and remove the class from there again. And I'm going to move my JSON printer to there. I'm going to move my XML printer to there. I'm going to delete the ones from here. Again, I'm going to just update the namespace, matching for purposes of this. I'm just going to make it match the assembly, which is not which you don't need to do, and in some cases is not desirable to do, but just for the purpose of this simplistic model, I'm going to do that. So I've now got my printing stuff out to a separate assembly. We'll notice here that I now don't have access to things like, so my score manager doesn't have access to the interface because I don't have because scoring is not related to printing. My program now can't create the XML printer because it doesn't know anything about printing. The score manager test won't work because they don't know anything about printing either. So what I'm going to do here, well, actually, I'm not even going to bother to do that, because I can see that I need to create a dependency now between scoring tests, demo app, all need to be dependent on printing, and that's not really kind of helping me, because if I then add something new to printing, it still kind of impacts on everything else, and that's not really what I wanted. So there's another step that I need to put in place in order to actually fully create separation in terms of the compilation between different parts of this, and that's to actually put the interface into its own assembly. And this is because Score Manager isn't dependent on our printer implementations. It's dependent on an interface. So if I can get it to a situation where my Score Manager is only needs to kind of worry about the interface, then I can mess around with the kind of printers as much as I like without impacting on the Score Manager. So I'm going to add another new library, which is going to be called printing interfaces. And I'm going to delete that class. And I'm going to move my printable interface to there. I'm going to delete that one from there. Now, if I look at these, and I'm going to leave that as the printing namespace. If I look at my printers, they are dependent on the printable interface, but they can't access that because there's a dependency needed between printing and printer interfaces. So I'm going to go and just give it that reference. So now we should see that our printers now have access to their interfaces. If I look at Score Manager, that also needs a reference to printing interfaces add-in. That should then fix that. If I look at my scoring tests, this still doesn't work because it doesn't like it doesn't have access to the printers. But given that my tests here are for scoring, I don't want my scoring tests to be dependent on printers. What I want to be able to do is use mock objects instead of printers, because I'm not testing printers. I don't care if the printers work or not. Printer code can be completely broken. I don't want to have to kind of worry about that. So I'm going to make sure that I've got a particular my mocking package in here. Let's just go to browse So I'm going to install the, and I only need that for scoring tests, so it's my testing application that's going to use the mock framework, nothing else is. So again, I'm trying to keep the amount of stuff that I need to compile, I'm trying for purposes of each particular bit of code, I'm trying to keep to a minimum. So having now installed the mock class, I can now say, and having through that process added the reference as well, I can say using mock, and I can now replace my XML printer by saying var mock printer equals new mock, and it's going to mock an interface. So iPrintable in this case, it's a new instance of that. So we can do that. We can get rid of that line. Now we'll see here that it still doesn't like that because it doesn't have a reference. It doesn't have a reference to our printing interfaces, but we're going to use printing there anyway. Now, interestingly, it's not complaining about. I'm just going to update that pass in the mock. So this again, this is kind of jumping over a few things. So if you're not familiar with kind of mock objects and what on earth is going on there, I'll add some links in the video to other stuff around the use of mock objects. But that is an essential part really of kind of effective testing. Interestingly, we haven't got a complaint about our access to the printable interface, even though we've not added a reference to the printing interfaces assembly. Let me just update both those lines so they use the same thing. This might look a bit crazy, but essentially what I would do is I would tell the mock printer, I can configure the mock printer object according to what I wanted to do. So I can tell it that it's going to be, I'm expecting JSON or whatever. I can do whatever I kind of want there. And in fact, it probably wouldn't even be relevant to test XML and test JSON here because the JSON and XML aspects of it are to do with the print and not to do with the scoring now. So the test itself is slightly kind of contrived, but hopefully it illustrates the point. If I now try and compile scoring tests, we will see magically. Well, that's interesting. Just trying to see what it's. So actually, so this is the reason, right? So something which I hadn't done, which I kind of thought I would have to do, but I don't have to do. We've updated the our scoring. So we've got quite a clever thing here. Our scoring tests are dependent on scoring. Our scoring is dependent on printer interfaces. Our printer interfaces have no dependencies. Printing is dependent on printing interfaces. See that? And we'll see that our demo app is not even compiling it. It's just not even working at the moment. So, and we don't even care about that. So we can see that our scoring test will build, and we can do stuff in here. We can go and break our printers. We can go and put in whatever nonsense we want in there. That's not going to compile. We can save that. That won't compile. Try and build that. So our printers broken. Scoring tests, wonderful. Scoring tests don't care what is going on with our printing. Just irrelevant. So we can go back in here. We can fix that. The reason why our main program file is not working, if we look at our dependencies here, we're only dependent on scoring. And scoring knows about printer interfaces. Printer interfaces, neither scoring nor printer interfaces know about printing. So I need to tell the main application about the printing interface, and I also, for the purposes of it, I need to tell it about the printing namespace there, and then it'll work. so when I, again, I can build my tests. It's nice and simple. I can build my main application. That has to do a bit more. So it has to build the interface. It needs to build scoring. It needs to build printing, and it needs to build the demo app. So when I build the full application, I have a bit more work to do. But when I want to run my tests for these things, so I can run my create object test again. If I run that again, I'll take that back to the build output. The work that it had to do in order to run that test was build the printer interface, build the scoring library, or I should say, build the printing interfaces library, build the scoring library, and then run the scoring tests. So none of the printer code had to be compiled. It didn't even have to work, let alone wait for it to compile. Likewise, the demo app is irrelevant to us. So I know slightly kind of contrived in this situation, but I hope it illustrates that we can get, through the use of assemblies and interfaces, we can really get some quite clear separation between our components. And this is a massively important sort of strategic aspect of how we code as our code base gets bigger. Not so important for smaller code bases, and arguably not so important if you don't care about the efficiency of your coding and you don't care about your ability to test. If you care about testing and you want your tests to be fast, you need to make sure that your tests are only dependent on the things they need to perform the tests, and that they're small enough to do that, and that when your code compiles, that you only that you don't compile more than you need to compile. Now there's a balance here. You could go and create a separate assembly for every single class file. That's madness. Equally, if you've got one massive application and it's all in one assembly, chances are you're not going to have so much efficiency in terms of running unit tests if you're having to kind of recompile code. So through this process, we can start to kind of use those assemblies to kind of group code together, get interfaces in the middle, and make our code dependent on those interfaces rather than being dependent on the implementation, and therefore start to make the amount of code that we need to compile in order to run our tests smaller. Therefore, it'll be faster. Our tests, therefore, can be faster. Again, this is all linked into that single responsibility principle as well. So what you don't want is lots of if you've got this kind of separation out, but then you've got classes that are doing massive amounts of stuff. You're still going to be kind of running into issues. You're still going to have problems with the on the testing side of things. So keeping the kind of classes nice and kind of concise, single responsibility, nice neat interfaces that allow code to logically be dependent on those interfaces rather than the main code, and then the tests that kind of are can really kind of bring a unit of that code, a single unit of that code under test, and use kind of mock objects and use the interfaces in order to do that. I'm hoping that this as an explanation of how assemblies can be part of that toolkit, rather than just creating big buckets that we arbitrarily just stuff code in there, stuff code in here, stuff code in somewhere else. We can actually create assemblies that do meaningful things. I should say that by by separating our code into different assemblies, it obviously means that code should be the code that we have in a particular assembly. So if we've got a printing assembly here, in theory, that should now be more reusable by other things that want to use, they want to be able to kind of print stuff, rather than just our demo app being able to do that, or that we can use something else. Something else might come along that implements the printable interface that does something completely different, and it should still work, in our code. So we might be able to, rather than printing XML or JSON, we might have something that sticks something up on a big, LCD screen or something, or whatever. We can do all those things. We're not kind of constrained in that way. So by creating those libraries, we're creating units of code that can be used. If the code is appropriate enough and the functionality is useful enough, can be reused elsewhere. The impact will obviously be the entire solution will probably take longer to compile as separate assemblies. But the upside is that the number of times that we need to recompile the entire code base should be reduced. And in fact, it means we can then potentially also our release process, we may, rather than releasing an entirely new set of code every time, you may release, you may update one particular DLL or something like that. So you're just make an update to a particular library. So you can start to get benefits that way as well. So smaller, not just a smaller release, but actually a release that only affects a smaller part of the application. So you're literally only changing maybe kind of one DLL within the entire application, which would be obviously a desirable situation. And hopefully, if you can get to a situation where assemblies are being effectively used, and interfaces are being effectively used, then the amount of time that you spend focusing on the quality of your code will increase. And obviously, you need to make sure that the code that you're compiling, you're keeping that to a minimum, and ideally that the test that you're able to run, there's as much automation in there as possible. And again, that may be through kind of unit testing or functional testing or whatever. I hope that's been useful.